I wanted to address this topic of differential equations that you're going to be doing in Calculus BC because we're going to be using it in AP Physics. And what we're going to do is this. I'm going to kind of look at it from the math perspective, and then we're going to adapt it to solving AP Physics questions. So the technique we're going to talk about, we talked about this last class, but I want you to review this and actually write what I'm writing and take notes on this because we're going to be using this like in the next 2 or 3 days. It's a technique called the separation of variables. So I'm going to start with one kind of differential equation that looks like this. So I have y prime minus 2y equals 0, and we want to know a function that satisfies this equation. That's the whole goal of differential equations. So given some kind of a differential equation, I want to know what's the function that when I plug it in and take all the derivatives and do all the algebra, it's going to satisfy that equation. Just to get a little bit more general here, there can be all kinds of ways of writing differential equations. I could say, maybe I'll take the second derivative minus y prime plus y triple prime cubed minus x. There's all kinds of horrible things that you can do in a class of differential equations to make students' lives miserable. So there's a whole course that you're going to be taking in college if you stay in this business. But for us today, we're going to focus on this equation. The first derivative minus a constant times the original function equals 0. And what we're saying is that this is the function that satisfies the equation. And it says demonstrate this by plugging it into the original equation. So here's what I mean by that. We're going to prove, just by substitution, that this function satisfies this equation, meaning that when we plug it in, it's going to actually make the equation work. So let's check it. So y equals c e to the 2x. Now let's take the derivative. Y prime equals, so the derivative of e to the 2x is e to the 2x times 2. So that's 2c e to the 2x. And now let's check this out. So is it true? Y prime minus 2y equals 0? You should be writing as I'm writing, by the way. So don't just be watching this video. You need to have pen to paper and you need to be doing this work. So we have 2 c e to the 2x minus 2 times y, which is c e to the 2x, equals, and what we find, so really what we're trying to do is we're saying y prime minus 2y. Does it in fact equal 0 if we have this? We plug it in. We see, 2c e to the 2x minus 2c e to the 2x does in fact equal 0. It checks out. This is the proper function that satisfies this equation. Try a different function and see it not work. Like try sine of x here and you'll see that it doesn't work. So here's our goal. Our goal in solving this equation is to use integrals to come up with a function that actually satisfies this equation. And that process is called solving the differential equation. So we're not solving like you do in algebra where you get a number. We're solving like you do in calculus and actually getting a full function that obeys this equation here. And that's going to be useful in AP Physics. So this is pure math class today. So what we're going to do is we're going to work backwards. I'm actually going to prove or come up with, like, how was I able to know that this is the answer? We're going to actually show you the process of solving this one particular differential equation. And then we're going to work through this today, and you're going to see how and why this particular differential equation is so useful for AP Physics. So first, I take this equation and I rewrite it. So this is called Newton notation with the primes, and we're going to rewrite it using Leibniz notation with the dy dx in place of the derivative. And you notice what I do here is I'm going to use this method called separation of variables. It looks like this. So it's dy dx equals 2y, and then from there I multiply both sides by dx. So that cancels the dx on the left side. And then I'm going to divide both sides by y here. and that'll cancel the y's. And so that's how I'm going from here to here to here. And what I'm going to do now is I'm going to use calculus to go ahead and come up with the solution to this differential equation. So the way we do this is so step one is literally separating out my variables. And what I mean by that is I'm separating my y variables and my x variables. So that's the beginning of the process. This is a step to memorize. So if you're wanting to know why or how did Mr. Abdullah come up with this, what was his brain thinking? What my brain was thinking was, what did I do sophomore year of college when my math professor made me do it? Back in the 90s. So way back in the 90s, in the days of Moses and Miriam and grunge music, this is what we did to solve equations. And now I'm passing this wonderful math on to you. So I didn't come up with this. I'm just reporting back to you on what I learned, and you can use this technique too. Now what I'm going to do is I'm going to integrate both sides like this. So I'm going to say that the natural log of y, okay, equals 2x plus, okay, I'm going to give my integration constant a different name. I'm going to call it C1, okay? It's just something we do in physics. Now what I'll do is I'm going to take e to the natural log of y, and that's going to, on this side, and then it's e to the 2x plus c1 on the other side. And so this e to the natural log of something is y, and here, this I'm going to write using, so let's remember this rule of powers. The rule of powers that says, oh my gosh. So here's what the rule of power says. E to the a plus b equals e to the a times e to the b. We're going to use that here to rewrite this as e to the c1 times e to the 2x. And I'm going to do a weird substitution that only physics nerds do. We're going to say e to the c1 is going to equal to a new constant, c. Just follow that rule. It's weird, but just go with it. And so y equals e to the 2x. And that is literally the answer. Our goal was to come up with y isolated that would solve this equation. So just to be clear, I want to just summarize what this algebra and what this calculus was. Okay, so we started with the differential equation. And we ended with a function y of x that satisfies the equation. Meaning, when we plug in y of x, it works, or it works in that equation. The goal for today, okay, we call this y of x the solution to the equation, and our goal is to use calculus and algebra to solve those differential equations. That's our whole goal for today on this part here. So notice we only have this specified up to an integration constant. What happens in physics is that we're going to be providing information that lets us come up with a specific value for this c. Okay. So specifically here, this is Newton's notation where the dot means a time derivative. So just to be clear, if I tell you y prime, that means dy dx. And if I tell you y dot, that means dy dt. So that'll be what we're going to do on this next page right here in our subsequent video.